Students, today we will start F.Sc Mathematics chapter number 3 exercise 3.2 integration. Question number 3 first part. Question number 1 third part. And the function of integration is integral x into under root of x plus 1 into dx. Here we know that the value of value of this under root is x power 1 by 2 plus 1 into dx. To solve this, first of all we will solve this algebraic expression. और उसके लिए हम क्या करते हैं कि इसको हम मल्टीप्लाई करते हैं, क्योंकि ये ब्रैकेट आ रही है इसके साथ x को मल्टीप्लाई करेंगे. एंड वी नो दैट व्हेन वी विल मल्टीप्लाई हियर द वैल्यू ऑफ दिस एक्सपोनेंट इज़ 1. व्हेन वी विल मल्टीप्लाई इट विद इन द ब्रैकेट वी विल गेट 1/2 प्लस 1 प्लस इसको जब x के साथ मल्टीप्लाई करेंगे तो ये x आ जाएगा इंटू डी एक्स. And by solving this power we will get the value of new exponent is 2 plus 1 3 by 2 plus x into dx. This is an algebraic expression and this is the easy one to solve. First of all we will integrate the first term, which is 3 by 2 dx, and after that we will integrate the second term, which is x dx. And here we will use the famous formula of integration, which is x power n is equal to x power n plus 1 over n plus 1. Here the exponent of x is 3 by 2, so we will add 1 in the power of x, which is 3 by 2 plus 1, and divide with the same exponent, the new one, which is 3 by 2 plus 1. प्लस सेकेंड टर्म के लिए हम क्या करेंगे, सेम है, यहाँ पर पावर 1 आ रही है तो यहाँ पर भी हम क्या करेंगे, ऐड 1. ये वाली 1 आ रहा है हमारे पास एज इट इज़, और इसमें हमने एक को ऐड कर देना है 1 को. हमेशा हमने 1 को ऐड करना है यहाँ पर. n प्लस 1, n से मुराद कोई भी पावर हो सकती है, 1 है यहाँ पर 3 by 2 है, लेकिन उसके अंदर हमने करना क्या है, इसके अंदर हमने 1 को ऐड करना है. सो वी विल ऐड 1 in the exponent of x over और डिवाइड बाय द सेम न्यू एक्सपोनेंट. न्यू एक्सपोनेंट हमारे पास क्या आ रहा है, वो 1 plus 1 है, प्लस सी इज कॉल्ड द कांस्टेंट ऑफ इंटीग्रेशन. आफ्टर सॉल्विंग इट वी कैन गेट 3 plus 2 is 5/2 over 5/2 plus again here 1 plus 1 is 2 over 2 plus c. This is double reciprocal, so it will invert the denominator. It will become 2 by 5 because of this double reciprocal, this one and this one, two reciprocals. X power 5 by 2 plus this is 2 in the exponent, or we can say it is 1 by 2 into x square plus c. This is our answer. So to check our answer, that is it right or wrong, we will take the derivative of this new function. This is the f of x, this is our function. So we will take a derivative of all of this function, which will become d by dx of x of f of x is equal to d by dx of all of this new function. And this new function is basically the answer or the solution of our first question. That's 1 by 2 x square plus c. So when we will take the derivative, we will get the same result, this one, x into under root x plus 1. So let's check what will happen. 2 by 5 into x power 5 by 2. Okay, 2 by 5, here power is 5 by 2. What we will do for the derivatives, power must be multiplied and we will must decrease the power by 1. Plus for the second term 1 by 2, again multiply the power and decrease power by 1 plus c, the constant. Whenever we will take the derivative of constant, it will become 0. Here 5 cancel out by 5 and 2 by 2, power 5 by 2 minus 1 will become 3 by 2 plus 2 cancel out with 2, x power 1, 2 minus 1 1. So here the common, if we take common, we can get x as common and the power will left 3 by 2 minus 1 will become power 1 by 2 plus 1. And here again we know that when we have a power 1 by 2 we can write it as square root of 1. And if we check our result we get that it's the same one. So we can say if we get the same result after taking the derivative of this integral, this is our main function, we integrate it and we get the solution, this one, and we don't know that our solution is right or wrong. To check that is it right or wrong, we will take the derivative of this answer, and if we get the same function which is given, this is x into under root x plus 1, is the same one, so it means that this answer is the right one, this is not the wrong answer. So 2 by 5 into x power 5 by 2 plus 1 by 2 x square plus c is the integration of our given function. Hope so you understand it very well. We will see in the next video. Bye.